Alright, so here are a couple sets of try problems to give you some good practice at finding slope, but then there's a second piece to this problem. Not only are you finding, I should identify where we're at. We are in 4.3 and the bottom of page 3 in the notes. So you're going to find the slope of the line passing through each pair of points. That part is just the same as we've been doing. You're going to be given 2 points, you find the slope, and you have 2 methods. You can use the formula m equals y2 minus y1 over x2 minus x1, or you can look at rise over run. Now the reason why I say you could use rise over run is because they give you a chance to graph it, because that's what they'd like you to do, is end up graphing both lines together. So 24a, that's line number 1, 24b, there's line number 2. You're going to graph both of these lines on the same graph. First they want you to find the slope of the line that passes through this point, and then they want you to find the slope of the line that passes through these 2 points. Okay, so I want you to hit pause. When you come back, I'll reveal what the slope is for each of the lines. Then I'll have you pause again, and after that I'll reveal the graph. Okay, so first, right now, just work on finding the slope of the line that goes through these first 2 points in 24a, and then again the slope for the line that goes through the 2 points in 24b. Okay, depending on the direction that you set up your formula, or if you plotted them on the graph and counted it off, you should end up with a -3/4 slope, or you might have gone 3 over -4. That's the same. Going down 3 to the right 4 puts you on the same line as going up 3 to the left 4. So those are both equivalent. And then the slope for these 2 points ends up being the same. Depending on how you set it up, you either got -3 over 4 or +3 over -4. And again, those are the same, those two are the same values to each other. If you had plotted those to count that off, if you using formula was one way, or you could have plotted the points. Let's see, 2, 4, sorry, that's not a point, and 6, 1, 1, 2, 3, 4, 5, 6. So you could have plotted those 2 points and then come up with the relationship, the movement relationship between them using rise over run. Or -3, 1, if we wanted to graph it over here, 1, -2, there we go, okay? So, in fact, that gets you partway through what you're supposed to do for graphing. So I'm going to have you pause it again, and now you'll graph both of these lines together, which means on the same grid, on the same coordinate plane. Okay? You might want to use 2 different colors to kind of help identify or label it. Alright, hit pause, come back, we'll see what we've got. Okay, so if you used the rise over run method to come up with the slope, that means you already plotted the points and all you had to do was connect. If you'd used formula to come up with slope, then, I hope I wasn't blocking there. If you used formula to come up with slope, then you needed to plot the points and draw the line between. So I've got my first line here. This is going to be line 1 in blue, and then I'm going to connect my other set of points, so I'll try not to block this time. And this is line number 2 down here in the pink. Notice I add the arrows at the end to indicate these lines go on forever. And the question is, what do you notice? Okay, the reason why they're having us do this particular type of problem now is so you can come up with a conclusion. And the conclusion is that both lines have a slope of m equal to -3 over 4, or 3 over -4. Those are the same. What you get in the picture is that the graph of them both together shows that the lines are parallel. That is not a coincidence. Same slope means parallel lines. They will never run into each other. They have the same movement as you go from point to point to point to point. Okay? They just happen to be in different starting places, so to speak. Okay? So, now, I'm going to leave you to this one completely on your own. I'm going to have you do both finding the slope of both of these, then going ahead and graphing it. So now you see what you're supposed to do. You're supposed to find the slope and graph it. When we come back, after you've hit pause, I'll reveal both the slope values and I'll show you the graph, and then we'll talk about what that means, what we're looking at. Okay, so you go for it, slopes and the graph. Okay, so hit pause if you still need more time there, of course, and here we go. Our slope for this first line is going to be 4 over 5. Depending on how you set that up, you might have ended up with negative 4 over negative 5, and that would cancel to become a positive. Negative over negative is positive. Okay, so this is going to be line 1 here. And line 2, between these 2 points, has a slope of negative 5/4. So one slope has 4 over 5, one slope has a negative 5/4. Let's go ahead and plot this first line. I'll use green here. The point 3, 2, so I go over 3 and up 2. And then negative 2, I go to the left 2 and down 2. And I'm going to connect that line. Okay, so there's line 1. I'll use purple for this second line here. It's the point 3, negative 2, and then the point negative 1, negative 1, 3. So I go left 1, up 3. Okay, and there I've got my 2 lines. Now, what do you notice about this one? This one may not be as obvious, but there is something there to notice, and that's why we're going to talk it through together right here. We've got slopes. They are different slopes. One is 4/5 and one is negative 4/5. They are negative inverses to each other, or they're the negative reciprocal of each other. So one is positive, one is negative, one is flipped from the other. Okay, so you've got 4 over 5, both positive, and then you get a negative 5 over 4. So it's flipped and then made negative. Or, one of them is positive, one of them is negative, and one of them is flipped. They're an inverse of each other. Okay, well, okay, is that coincidence? Does that mean anything? Actually, it does. Depending on how accurate your little graph was here, you should notice that, or you should be able to be pretty convincing that these 2 lines have a 90-degree angle between them. They cross each other at a 90-degree angle. They're known as perpendicular, which you may have started to see that was coming because we either talk about parallel or perpendicular lines. So there's a particular relationship when you have same slopes, it creates parallel lines. When you have negative inverses of slopes, one positive, one's negative, and it's flipped, you get perpendicular lines, which means they cross at 90 degrees. Okay, so little tidbit to kind of tuck away as we use later on in a couple different problems. We'll see you on page 4. Good job.